Hello, Nitya.
Ma'am?
Join ஆயிட்டேன். ஓகேவா?
Okay, ma'am. Okay, ma'am.
ஃபேஸ் தெரியுதா?
Clear இருக்கா ma'am.
ஒரு நிமிஷம் நான் இப்ப பாரு. இப்போ ஓகேவா?
Okay, ma'am.
ஓகே ரைட்.
Ma'am, shall we start, ma'am? Ma'am? Jabin ma'am, can you hear me?
Yeah, wait a minute, Nitya.
Okay, ma'am. Okay.
Wait a minute, Nitya.
Okay, ma'am.
Okay. I am audible?
Yes, ma'am. Yes.
Yeah, we can start.
Good afternoon to all the participants. I welcome Dr. S. Jabin Beham, ma'am, Professor, Head of the Department CSC, Vellalar College of Engineering and Technology. I really happy to introduce our resource person. She completed his UG degree at Periyar Maniammal College of Technology, Vallam. She completed his PG degree in the year of 2007 at Government College of Technology, Coimbatore. She also completed PhD in the year of 2013 at Anna University, Chennai. He's totally having 28 years of teaching experience in engineering college. Now she's currently guiding 3 research scholars in cloud, data mining, and security areas. She published 12 national and international journals. He's presented more than 45 papers in national and international conference. She's also chaired and acted as a resource person for AICTE, CSIR, ICMR, DST sponsored seminar, workshops, and FDPs. She program organized under AICTE, CSR, ICMR, DST. She received 3 times Best Teaching Faculty Award and received a Cloud Champion Award for organizing and interacting with ICT Academy. He is a professional body member for ISTE, CSI, ISSC. I was really happy to welcome you, ma'am.
Thank you, Nitya. Shall I share my screen?
Wait, ma'am.
Kindly convert me as host.
Now I make you as host, ma'am. You can share your PPT.
Thank you, Nitya. Thank you for my short and sweet introduction.
Thank you, ma'am. Thank you, ma'am.
Thank you. I think my screen shared. I think so. Yes. Okay.
No, ma'am. It's not shared. No. It is in the directory, ma'am. 2820 scope of research deep learning. It is inside the IT STTP directory.
Yeah. But it is not sharing. No.
No,
not shared.
No, ma'am. No. Your PPT is not visible, ma'am.
Whether my wait a minute. Now?
No, ma'am. Ma'am, again you give stop sharing and again you share your.
Okay. Now visible?
Then it is inside the directory only.
Now? No.
Ma'am, I think you are not selected your presentation.
Okay, I'm selecting, but I don't know why. Wait a minute, Nitya.
Morning also we made
same problem.
Ma'am. Yes, ma'am. Arun try to present the
Now I am sharing. Yeah, actually, okay, wait a minute. Now I will open my and then I download. Okay, okay. Uh, now share screen. Is it visible now?
No, ma'am. Now
No.
it's visible,
Ah,
ma'am.
yeah,
Now,
yeah.
now.
Yeah. Okay, right. Okay, right. Yeah. So, a very good afternoon to one and all present over here. And today's topic is actually scope of research in a deep learning. Very good topic, I think so. And then it's the right time for our college to actually conducting such a STTP sponsored FTP for the faculty members. And hope for the past 5 days, faculty members learned a lot, and this is the final day, and I think surely I'll give some research area and eye opener for the research scholars. Hope, I think so, and thank you very much for the opportunity given to me. Thank you. And now we'll start. And the first thing is, what is a scope of research in deep learning, we can say. So the influence and impact of deep learning can be seen in everything, from our morning coffee and then orders to the online banking applications we use. So the technology is infusing a deeper intelligence and understanding into the applications that touch our lives and dramatically improve our experiences. In addition, is helping to span entirely new business innovations and methods such as autonomous vehicles and virtual personal assistants. In fact, deep learning is so prevalent and pervasive, and that it's very difficult to imagine an enterprise being able to survive without embracing it in the next 5 years, especially considering predictions of continued global data growth. And this is why it is not only important, but critical to understand the current state of deep learning and what the future holds. So next, according to Wikipedia, I can say that this deep learning is nothing but the class of machine learning algorithms that use multiple layers to progressively extract higher level features from raw input. For example, in image processing, lower layers may identify edges, while higher layer may identify human meaningful items such as digits or letters or faces. So in real life, we learn from experience. So similarly, deep neural networks perform each task iteratively, then resulting in learning from every iteration result in a better outcomes. Okay, so why it's called deep learning? That is very important. Then because of neural networks works on a ton of deep layers that boost up the learning of algorithms, and in modern era, a massive amount of data is generated in addition to more creation. And then DNN algorithm gains a stronger computing power that's available today, as well as the qualification of artificial intelligence as a service. Okay, so this is the main concept, right? And then what actually this slides wants to show something is nothing but artificial intelligence and machine learning, as well as deep learning. So three terms that are usually used as synonyms, although there are differences between them. Then I can say that artificial intelligence is the overreaching discipline that covers anything related to making machines smart. Then AI allows actually machines to learn from experience. The machines adjust the responses to perform human activities by processing data and recognizing patterns in them. So whether it's a robot or a refrigerator or a car or a software application. So if we are making them smart, then it is nothing but artificial intelligence. So machine learning is a subset of artificial intelligence. It enables machines to learn by themselves through the use of given information. So machine learning algorithms try to minimize the errors and maximize the possibilities of their predictions to be true. So machine learning systems get smarter and smarter over time without human intervention. And now coming to the deep learning. So deep learning is a we can say that it's a part of machine learning in which artificial neural networks are inspired by the human brain neurons or perceptrons that basically learns from a large amount of data. Okay. And next is nothing but we can say that deep learning, and deep learning is nothing but we can say that it is a computer software that actually mimics the network of neural of a like a brain. Okay. So we can say that you all know that it's actually a subset of machine learning, and even the machine uses different layers to learn something. Okay. So that is the concept of deep learning. And now coming to this, this neural network is, we can say that it's a branch of machine learning under reinforcement domain, which is actually used in prediction of any variable from a given raw data through network-like structure. Okay, so neural networks structure is mostly likely to be a human neural system, and here it got nucleus at the center part, and dendrites to receive electrical signals, and axon for signal passing, and axon terminals for signal output to detritus, another neuron. So here the first layer is actually we can say that it's an input layer, and the last layer is actually the output layer. So all the layers in between are called hidden layers. So the word deep means the network join neurons in more than two layers. Okay. So for hidden layers, it is composed of neurons. So the neurons are connected. The neurons are connected the neurons are connected to each other, and we can say that the neuron will process, then propagate the input signal. It receives the layer above it. Okay. So the strength of the signal given by the neuron to the next layer depends over the weight bias the activation function. Okay. And then next actually here each input we can say that goes into a neuron and multiplied by a weight, and the result of the multiplication flows to the next layer and become the input. Okay, so this process is actually repeated for each and every layer of the network, and the final layer, that is the output layer, provides an actual value for a regression task and a probability of each class for a classification task. Okay. So the neural network uses a mathematical algorithm to update the weights of all the neurons. And the neural network is actually fully trained when the value of the weights given an output choose the reality. So all these things, I think, so you have come across, okay, for the past 5 days, but basic things here I am explaining. Okay, the main thing what actually really need. So here there are different types of neural networks being used in deep learning algorithms, and some of them are mentioned in the slide. Actually, we have to, here we are having a perception, then feed forward, and then a radial basis network, then recurrent neural network, and long and short term memory, and then gated recurrent, then auto encoder, and variational AE, and denoising. So all these are the different types of deep neural networks. Okay, and next one is nothing but the that is the feed forward neural networks. So what actually this feed forward network is nothing but we can say that it is the basic where it is actually start with the basic network with the feed forward network, and it is a network where the data only flows in a forward direction and no backward flow is allowed here. Okay, so that is here we can say that the data is fed at input layer, and further it is carried out to the hidden layers. Okay, so the processing of the input variables in the hidden layer is done according to the activation function applied to that node, and that later it carried forward to output layer, where output will be taken according to the activation function. So what actually here the activation function means here the different types of activation functions are available. We can say that sigmoid, then activation function, and then a tangent, then hyperbolic activation function, and all these things we are using. Okay. And next one is nothing but the recurrent neural networks. Okay. So this recurrent neural network comes into a picture when any model needs context to be able to provide the output based on the input. Okay. So sometimes the context in the single most important thing for the model to predict the most appropriate output. Okay, so in other neural networks, all the inputs are independent of each other. Okay, so but in RNN, all the inputs are related to each other. Okay, so let's understand with a simple example. We can say that. So suppose if you are watching a movie, and if you keep watching the movie at any point of any point in time. Okay, so we can say that. So if you have a context, because you have seen the movie until that point, then only you are able to relate everything correctly. Okay, so it means that you remember everything that you have watched similarly, and then the same thing this recurrent neural networks says. Okay, so that is the main thing. Okay, so when you are watching a movie, and then it is very easy and you can remember for all times. Okay, so this is the example. So another one example here I am showing you. And here very simple, here we are given one simple sentence. It is given, do you want a dash? Okay, so here the RNA neurons will receive a signal that point to the start of the sentence. Okay, so here every word is taken. Okay, so the network will receive the word as the word do as the input and produces the vector of the number. And this vector is actually fed back to the neuron to provide a memory to the network. And this step helps the neural network to remember it received the word do. Okay, in the first position. Okay, so the network will similarly proceed to the next word, and it takes another word you. Okay, so it's going on. So final stage is nothing but up to it will receive. Okay, so the neural network will provide a probability for each and every English word that can be used in a complete sentence. So a well-trained RNN probably assigns a higher probability to all these different things like drink, burger, and all these things. Okay, so this is the concept. This is a simple example of RNN. Okay, and another important thing is the next one is the convolutional neural networks. Okay, so what is this CNN? So we can say that this CNN is nothing but it is a multi-layered neural networks with a unique architecture designed to extract increasingly complex features of the data at each layer to determine the output. Okay, so these CNN are inspired by the brain. So similar to how children or child learns to recognize objects. So here we need to show an algorithm millions of pictures because it is able to generalize the input and make predictions for images has never seen before. Okay, so like that. Okay, so next one is here the same thing. The computers, for example, we can say see in a different way that we can do. Okay, so there we can say that computer world is different and it knows only numbers. Okay, so for every image can be represented as two-dimensional arrays of numbers known as pixels, but the fact that they perceive the images in a different way. So doesn't mean that we can't train them to recognize patterns like we do. Okay, so we just have to think of what an image is a different way. Okay, so to teach an algorithm how to recognize objects and images, we use a specific type of artificial neural network, a conventional neural network. Okay, so their name actually stems from one of the most important operation of the network convolution. Okay, so we can say that what is really that's a convolution. What is here is nothing but is a mathematical operation actually which describes a rule how to mix two functions or pieces of information. So the feature map, the convolution kernel mixed together, and then a transformed feature map like P. Okay, so a convolution is often, we can say that interpreted as a filter, and then where the kernel filters the feature map for information of a certain kind. Okay, so that is the thing. Okay, and then here, next important thing, what actually we should know is nothing but the reinforcement learning. So it is actually, we can say that this refers to a goal-oriented algorithms which learn how to attain a complex objective or how to maximize along a particular dimension over many steps. For example, they can maximize the points won in a game over many moves. Okay, so this reinforcement learning can stand from a blank slide, and under the right conditions, they achieve superhuman performance. So like a pet incentivized by scolding and treats, these algorithms are penalized when they make the wrong decisions and rewarded when they make the right ones. So this is the reinforcement. And the different types of famous algorithms are available. We can say that Q learning, deep Q network, and then state action or reward state actions, and then deep deterministic policy gradient. Different algorithms are available. I think all these things you may come across. Okay. And next one is nothing but the how the machine learning process is performed or done. Okay. So the first step is actually we have to extract the features. Okay, and choosing features, and we have to manipulate the data set. Okay, and next we have to split the data set. Okay, so train and SLE, we have to test the data set, and then you have to train the model. Okay, and input train data set into a machine learning model, and then we have to evaluate. And if desired performance we are not at reach, then automatically we have to repeat the process. So that is the main process. Okay. And here in the deep learning, some steps we are, a small difference, we can say that. Okay, so extract features are same and split the data set. Okay, and train model. Okay, so here in train model, input train data set into a deeply connected network that is number of connected layers will be there, and then we have to evaluate a small change. Okay, and then we are going to give the inference, and then we are getting the output value. So a small difference is there. Okay, right. And next one is important thing is here we may have different types of task learning system. Okay, either it may be a single task, so we can divide the learning process into two. Okay, one is single, another one is a multiple. Okay, so this single task learning in which different tasks are done by different neural networks. Okay, so this is what the picture actually says. Okay, then each individual task is solved separately by its own network, and each network is trying to predict a unique result. Okay, so researchers shows that single task learning sees a significant decline in performance when less training annotations are present. Okay, and next one is the multitask learning. And then in the picture itself, you may seen the difference, how the single and multitask learning are different. Okay, so whereas in multitask, we can say that all the predictions are done by a single neural network within n layers, giving the desired output. Okay, so multitask learning has been used successfully, we can say that across all applications of machine learning, from a from a natural language processing and speech recognition to computer vision and drug discovery and everything. Okay, so if you are trying to optimize more than one loss function, then you are effectively doing multitask learning. Okay, and then even if you are only optimizing one loss as is the typical case, then chances are that is an auxiliary task that will help you to improve upon your main task. Okay, and this is the main difference between the multitask learning and the okay. And another important thing I think is the visual future learning. Okay, so what is actually this visual future learning? So we can say that human learns robust and efficient strategies for a visual task, and we can say that through interaction with any other environment. In contrast, most current computer vision systems have such learning capabilities also. Okay, and then the learning objective is actually to select a small number of highly useful features from their space in a task driven manner. Okay, so features are learned by general to specific sampling. Okay, so here we are having a stack and convolutional and as well as the auto encoder. Okay, so these things are available. Okay, so the auto encoder is actually trained to encode the input into a representation in a way that input can be reconstructed. So the target output of the auto encoder is thus the auto encoder input itself, and hence the output vectors we can say that have the same dimensionality as the input vector. So in the course of this process, the reconstruction error is being minimized and the corresponding code in the learned feature you are getting. Okay, so this is the concept behind the visual feature learning. Okay, and next one is important thing. So how the applications, we can say that the application of neural networks. So here this handwriting recognition. So the written digit recognition is the ability of computers to recognize human handwritten digits. It is a hard task for the machine because handwritten digits are not perfect and can be made with many different flavors. Okay, so the handwritten digit recognition is the solution to this problem, which uses the image of a digit and recognize the digit present in the image. So we can say that this is the thing actually you are seeing. So this is the handwritten images, and most probably the people will easily understand what actually it was written, but it is somewhat difficult for a system to recognize. So take this particular thing. So here we can say that the MNIST data set contains 60,000 training images of handwritten digits from 0 to 9 and 10,000 images for testing. So here the MNIST data set has 10 different classes, and the handwritten digits images are represented as a 28 by 28 matrix where each cell contains a grayscale pixel value, and they're continuing. Okay, so this is the main concept behind the working principle. And here another thing, here also I'm showing you the how this particular thing is working. So the image data cannot be fed directly into the model. So here we need to perform some operation and process the data to make it ready for our neural network. Okay, so the dimension here I have told we are using a totally 60,000 training images and with the matrix of 28 by 28. So here we are taking 60,000 28 by 28, and here we are adding one value. The CN model will require one more dimension so has to reshape the thing. Okay, so that's why here we are adding one more dimension of one value. Okay, so here some functions I have given some basic approach how the binary classifier works, and then here we are having some methods are given that MNIST load data, and then a MNIST fit load function. That Keras will start the training of the model, and it takes the training data and validate, and then the value backspace. Okay, so this is the thing processed in the thing. Okay. Okay, so we'll see some of the examples of deep learning at work. Okay, so here different types of examples are available. For example, automated driving, aerospace in defense, medical research, industrial automation in electronics, and then even banking, insurance, healthcare. Okay, so all these things, even we can say that that particular deep learning is everywhere. Okay, internet, cloud, medicine, and then in media, in even the security side, and in even in the automation, autonomous machines. Okay, in every. Okay, so here this particular deep learning, we can say that changing the way we look at the technologies. That is the thing. There is a lot of excitement around artificial intelligence, along with the branches, namely machine learning and as well as deep learning. So we can say that with the massive amounts of computational power, machines now it recognize objects and translate speech in real time. Okay, so this artificial intelligence is actually finally getting smart. Okay, so it's predicted that many deep learning applications will affect your life in the near future. We can say, okay, actually there are already making an impact within the next 5 to 10 years. So this deep learning development tools, libraries and languages will become the standard components and every software development toolkit. So it's surely it will think. Okay, so even we can say that this particular deep learning using self-driving cars, used in self-driving cars, and then in even in the deep learning in the healthcare, and then voice search and voice activated assistants. Okay, in all these things we are using, and even for image recognition things. Okay, so we can say that image recognition is also possible because we have seen one simple example. So in that a simple example, we have come across how the handwritten things are identified. So like way, so image recognitions are very, very important. Okay, so it actually aims to recognize and identify people and objects and images in images, as well as to understand the content and as well as the context. That is the main thing behind. Okay, and even we can say that in advertising also we are using this deep learning process, and even we can say that in predicting the earthquakes, we may use deep learning, and even for neural networks for brain cancer detection. In all these things we may use. Okay, banking, insurance, in healthcare. Okay, and then in automotive, even in case of government sectors. Okay, so we can make use of this thing. Okay, so even we can say that these new networks may be used in finance and as well as in price for market price forecasting. In all these things it may surely we can say that the step is available. Okay, all the things. Okay, and then coming to the real time applications of deep learning, you can say. So here the first thing is nothing but the automatic colorization of black and white images. Okay, so this particular image colorization, colorization is the problem of adding color to a black and white image, we can say, and then photographs. And traditionally, this was done by hand with the human effort because it is such a difficult task, we can say that. But deep learning can be used to use the objects and their context within the photograph to color the image. I mean, much like a human operator might approach the problem. Okay, so very simple. And a visual highly impressive fact it will give. Okay, so that is the main concept behind. Okay, and next one is nothing but the automatically adding sounds. Okay, so we can even add some of the sounds to the movies. Okay, so in this task what actually we are doing is nothing but a system. The system must synthesize sounds to match the silent movie or video, we can say. So the system is actually trained using 1,000 examples of video with the sound of a drumstick striking different surfaces and create different sounds. And then a deep learning model associates the video frames with the database of pre-recorded sounds in order to select a sound to play that beat matches what is happening on the screen. Okay, so here the main important thing is you have to match with the silent video. Okay, so the system is actually evaluated using the Turing test like setup, and where humans had to determine which video had the real or the fake sounds. Okay, all these things. But using the convolutional neural networks algorithms, we can do the process. Okay, the next important thing is nothing but the automatic machine translation. So we can say that automatic machine translation. So here this is a task where given words or phrase or a sentence in one language automatically translate into another language. Okay. So automatic machine translation has been around for a long time, but deep learning is achieving the top results. So here we can say that automatic translation of text or automatic translation of images and all these things are possible. And next important thing is nothing but the object classification and the detection of photographs. So this particular task requires the classification of the objects within the photograph as one of the set of previously known objects. Okay, so then only easily we can compare and then we can do the process. Okay, and here the state of art is very important. The results have been achieved on benchmark. For example, we can say that this problem using the very large convolutional networks, and a breakthrough in this problem is given. Okay, so a more complex variation of this task called object detection involves specifying and identifying one or more objects within the scene of the photograph. And next one actually we have come across already, that is automatic handwriting generation. So this task were given a corpus of handwriting examples to generate new handwriting for a given price. Okay, so this is the main concept. Okay, and next one is nothing but the automatic text generation. We can say that automatic text generation, and this is actually an interesting task where a campus of a corpus of text is learned, and from this model new text will be generated, word by word or by character. So this particular model of capable of learning how to spell, then punctuate from sentences, and even capture the style of the text of the corpus. Okay, and next one is the image. We can say that automatic image caption thing. And image caption is nothing but here capturing is the task where given an image, the system must generate the caption that describes the contents of the image. Okay, and then here in 2014 there were an explosion of deep learning algorithm achieving very impressive results of this on this problem, leveraging the work from top models for object classifications. So once you can detect objects in photographs and generate labels for those objects, you can see that the next step is actually to turn those labels into a coherent sentence description. Okay, so this is one of those results that knocked my socks off, and as well as still does. So very impressive indeed. Okay, so that is the thing. And next important thing is the game playing. So we all know that games are not only entertainment, though, but anyhow. So training a virtual agent to outperform human players and to optimize a score can teach us how to optimize different processes in a variety of different and exciting subfields. Okay, so this is the process here we are doing. Okay, right. Next one we'll see. So we know that DL is used for everywhere. Okay, so DL is actually we are using in everywhere. In terms of main thing is a variety of range of applications, and which is led to a rise in its popularity and its usage. It's in various industries, and we can say that in image recognition, then fingerprint recognition, then open source platforms, and then banking apps, then medical research, and then business trends, and as well as in automotive thing. Okay, in all these things we are using the deep learning techniques. Okay, and even we are having different things like automated machine learning things, and then hybrid learning models, explainable artificial intelligence, then drug discovery, then navigation. In all these things we are having. Okay, so the future directions of deep learning is everywhere. We can say everywhere. Okay, so it will actually adopt a core set of standards and tooling frameworks, and it is destined to be endorsed and demanded by several brands and businesses, and then fast coding through simplified programming frameworks, and then it will be increasingly used in field of designing and building, generative designing work, and image search. Then we can see the resolution enhancement, and then various other applications of deep learning is that. Okay, we can say that the deep learning, it's all around us. So today, the deep learning methods are used to continually to improve the personalization of specific technologies. So within an enterprise, unique algorithms and models are built to power everything from fraud detection and recommendation engines to medical image classification and aircraft schedule. Okay, so for example, the fraud currently cost the financial industry approximately, we can say that so many millions of billions of dollars. Okay, so even we can say that some of the fraud detection is found in ATMs, and while you are withdrawing the amount, and then even credit card fraud is done. So for all these things, we can easily make use of this deep learning, and then we can create a solution. Okay, so another important thing we can say that okay, so in future direction, even we can say that this deep learning will have a very good, I mean, we can say that a long-term goal. Okay, the deep learning is having a very long-term goal, and then even we can we may implement in this kind of solar system, and then even the astronauts, they'll use deep learning for measuring the water scarce. Okay, and even these deep learning, we are having different tools and everything. Okay, so what actually this future direction of this particular deep learning? The first important thing what actually they are saying is the core set of standard tools. Okay, so we can say that a core set of standard tools. So by the end of this decade, we can expect the deep learning community will converge on a core set of factor tooling frameworks. So currently, deep learning professionals have a glut of tooling options, most of which are open source. Okay, so the most popular, which include, we can say that TensorFlow, then BigData, and then OpenDeep, and then Caffe, then TARS, and then the MXNet. Okay, and then next one important thing is nothing but the deep learning will gain native support within Spark. Yes. So the Spark community is actually will beef up the platform's native deep learning capabilities in the next 12 to 24 months. And we can say that it's judging by the sessions at the recent Spark Summit, it would appear that the community is learning toward a stronger support for TensorFlow at the very least with BigData. Okay, and then Caffe and as well as Torch. Okay. And another important thing is nothing but deep learning will find a stable niche within the open analytics ecosystem. Okay, so most deep learning deployments already depend on Spark, Hadoop, and other open source data analytics platforms. What is becoming clear is that you can't adequately train, manage, and deploy the deep learning algorithms without the full suite of big data analytics capabilities provided by these other platforms. Okay, so in particular, we can say that this Spark is becoming an essential platform for scaling and accelerating deep learning algorithms built in various tools. Okay, so as I noted in this recent article, many deep learning developers are using Spark clusters for such a specialized pipeline task as hyper parameter optimization, fast in memory data training, data cleaning, data cleansing, and as well as the pre-processing. So we can expect more from deep learning. Okay, and next important thing is nothing but the deep learning tools will incorporate simplified programming frameworks for fast decoding. Yes, we can say that the application developer community will wait a minute. Hello. Hello?
We can able to hear you, ma'am.
Yeah. So we can say that the application, the developer community will insist on APIs and other programming abstractions for fast coding of the core algorithmic capabilities with the fewer lines of coding. Okay, so only a small amount of coding is required here, and even we can say that here these deep learning developers will adopt integrated open cloud-based development, and then environments that provide a wide range of the shelf of pluggable algorithms, libraries, and everything. And next important thing is the deep learning tools will incorporate simplified programming frameworks for fast coding. Okay, so this particular deep learning toolkits will incorporate modular capabilities for easy visual design, configuration, and training of new models from pre-existing building blocks. And many such reusable components will be sourced through transfer learning from prior projects that address similar use cases. Okay. And next important thing is nothing but the deep learning tools will be embedded with every design surface. Okay. So it is not too soon to start envisioning the thing, but within next 5 to 10 years, the deep learning and development tools, libraries, and languages will become standard components and then of every software development toolkit. So equally as important, we can say that user-friendly deep learning development capabilities will be embedded in generative design tools used by artists, designers, architects, and creative people of all stripes who could never go near a neural network. Okay, so driving this will be popular mania for deep learning neural network, and we can say that as a deep learning market advances towards mass adaptation, and it will follow the footsteps of data visualization, business intelligence, and predictive analytic markets. And all of them have moved their solutions toward self-service cloud-based delivery models. So that delivery fast value for users who don't want to distracted by the underlying technical complexity. So that's why the technology evolves. So these are the some of the applications and future directions we have come across, and the scope of research area is very high. But again, so whatever be the technology and whatever be the new things are arriving, the main concept here is the thing what actually we have to concentrate is what are the different types of techniques and what are the different types of algorithms we can write by ourselves, and how we can develop our own techniques, and then so that we can adopt into the deep learning. And another important thing it will arise is nothing but the security. Okay, so whatever be the technology arises, the security lies a vital role. So here the researchers must concentrate much more on the security area also. So we all know that for the past 30 or 40 years, okay, for the past 40 years, so we are learning a lot, and then but the security is playing a vital role in this. Okay, so like here in deep learning also, we know that this particular security will surely, so some flaws will be there. So the researchers make also concentrate on the security related areas also. Okay, right. So next one, I'll show you one small latest AI and the deep learning technology innovation thing. Wait a minute, I'll share. Hope my screen is shared. Yeah, my screen is sharing.
No, ma'am.
No.
It's still in your presentation.
Wait. The screen is actually past, I think so. Okay, wait a minute. No?
It is not visible.
Okay, okay. So one video I want to share, but I don't know why it's not sharing. Okay, so what? Whether my screen is, oh no, my screen is also not shared, I think so. Host, disable the participant, okay. My screen is not shared. But my PPT? No, my PPT is also not shared.
Ma'am, now you try to share your video, ma'am. I make you as a host again.
Oh, you, okay, okay, wait a minute. Share screen. STTP. No.
Ma'am, I think again you try, ma'am.
No, 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 it is not shared. Okay, 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 no problem. Okay, no problem.
Ma'am,
So lot,
the
yeah,
video, it's a latest AI and deep learning
yeah,
technology.
yeah. That's the thing I want to share, but I don't know why the screen is not sharing. Hmm?
Ma'am, just you click on that, ma'am.
Yeah, but I don't know.
You click on it, and after that you try to share your video, ma'am.
Okay, okay, wait a minute. Okay, Nitya, it's not sharing. I don't know why. Okay, Nitya, no problem. Okay, Nitya, so thank you very much. I think somewhat I have covered this applications and then research area of deep learning, and you have learned a lot for the past 5.5 days. And this is I think this is the application area where we can use the deep learning, and then many innovative things are available, and there is in automatic coding, healthcare, and then even in the banking applications and everything. Okay, so thank you very much for the patience, and thank you. Nitya, please.
Thank you so much, ma'am. I definitely it was a fruitful and amazing time for our participant to listen your session, ma'am. Thank you once again.
Thank you, thank you, thank you.
Participant, you can rejoin at 2:45 for the validatory function.
back, participants. Now I'd like to invite Ms. R. Mageshwari, as Professor of Vellalar College of Engineering and Technology, to deliver the valedictory address.
I welcome you all for the valedictory session of 6 days online AICTE sponsored short-term training program series 2 on deep learning applications and its challenges in big data analytics. It is a great pleasure and with sense of fulfillment I present this valedictory speech. I consider it as a great privilege to propose thanks to all the dignitaries who have witnessed it as a memorable and successful event. I especially thank AICTE STTP chairman to provide us an opportunity to conduct this online STTP from 7th September to 12th September 2020. I would like to thank our college secretary, Through S.T. Chandrasekhar sir, Principal Dr. M. Jayaraman sir, Dean Academics Peter Stanley Bevington sir, and Dean Student Affairs Professor Jayachandran sir, and Dean Controller of Examination Dr. K.R. Valvan sir, for providing technical support for the smooth conduct of this online STTP. On behalf of management, I extend a very hearty thanks to all the resource persons from various industries, colleges, and universities from all over India to share their knowledge and experience through this online STTP. I would like to express my sincere thanks to the STTP team of BCET to bring this STTP a successful one. Thank you.
Thank you, ma'am. Kind information to all the participants. We have shared the feedback, attendance, verification, and the test link to your WhatsApp group. Kindly give a response for that. Then a 50% score is a mandatory to get a certificate. The certificate will be sent to your registered mail ID within 7 working days, as well as the presentation material will be shared along with it. We are happy to say that the next series of this STTP will be conducted from 12th to 18th October 2020. The participants who are unable to participate in the series can register for the next series. Once again, I thank you all for making this STTP as a successful one.
Oh, excuse me, ma'am.
Yes, sir.
Excuse me.
Yes, sir. Yes, sir.
I'm Dr. Kumar from SIRT.
Yes, sir.
The Facebook. मैम आपने भी बोला कि वेरिफिकेशन लिंक नहीं है मैम.
Sir, quiz link, sir.
Ma'am, you have said about the verification link. One was the feedback link, one was the test link, one is the verification link.
Yes, sir.
Ma'am, please provide the verification link.
Link is nothing but your attendance verification link, sir. We are going to download your attendance from the Zoom cloud. We are going to verify that with the Google response that you are given today.
Okay, ma'am. Thank you.
Okay. Participant, any clarification you are needed? Verification link under test. The test link will be closed today at 9 p.m. So kindly submit as soon as possible.
So thank you, participants. So as of now, I think there is no doubts from participant side. And if you have any queries, you feel free to share the same through WhatsApp. So we will answer you as it is possible. Okay. Thank you, participants. We will wind up the session now.